Hello everyone. In this video session, we will solve some more problems on probability. This question number 6 is a question which is being asked in Karnataka's PGCET examination. So asked PGC, Postgraduate Common Entrance Test for the year 2016. Right. So let's understand the question. A box contains 8 red, 3 white, and 9 blue balls. If 3 balls are selected at random without replacement, let me put a comma, the probability of getting at least one white ball is what? So there are these 4 options. Let's try to solve this question. So primarily the question talks about, let me put it like this. So 8 red, 3 white, and 9 blue balls. That means totally there are 20 balls. So out of these 20 balls, we need to choose 3 balls at random without replacement. That can be done in 20C3 ways. So that means this will be our total or number of all possible outcomes. All possible outcomes. Right? But what is the question is the probability of getting at least one white ball. At least one means minimum one white ball. Means it can be one white ball, or it can be 2 white balls, or it can be even 3 white balls. Maximum it can be 3 because there are only 3 white balls. So based on this information, let us try to calculate the probability of this. So the required probability is equal to, so we know all possible outcomes, that will be the denominator. So denominator will be 20C3. Numerator. So as we saw, I can choose 3 balls in such a way that one should be, at least one should be white ball. Means, how do we do it? Out of total 20 balls, we are going to choose one white, at least one white ball. How many white balls are there? There are 3 white balls, out of which I need to choose a minimum of 1. Right? That means the balance 2 balls can be from any of the remaining 17 balls. That is one option. Or, so when I say or, I will put addition symbol. 3 out of those 3 white balls, I can choose 2 white balls, and from the remaining 17 balls, I should choose 1 white ball. Why? Because this sum, that is this 1 and 2, that should total up to 3. This 2 and 1, that is also totaling up to 3. Because you are ultimately choosing 3 balls. So plus, I can choose all of the white balls. That means from the balance, I will be choosing none. It is 0. Right? So we need to now evaluate this. 3C1 will be 3. 17C2 will be 17 into 16 by 2 plus 3C2 is nothing but 3C1. By using the formula NCR is nothing but NC n minus R. So 3C2 can also be considered as 3C1. 3C1 is nothing but 3. 17C1 is nothing but 17. So just a minute. Okay, so this is 17 plus 3C3. 3C3 is nothing but 3C0. 3C0 is 1. 17C0 is also 1. So the denominator is 20C3, that can be expanded as 20 into 19 into 18 divided by, I will write in the denominator 3 factorial, 3 into 2 into 1. So this goes with this 8 times, and this goes with this 10 times, this goes with this 6 times. So that means this, if I evaluate, first term will be 408, second term is 51, third term is 1, denominator will be 1140, or this can be written as 460 divided by 1140. So I can divide numerator and denominator by 10, so you get 46 by 114. Further, I can simplify. If I divide both numerator and denominator by 2, I will have 23 by 57. Is there an option like this? Yes, it is option. Right. So let's proceed to the next question. If A and B are mutually exclusive events and P of A is known to be 0.29, P of B is known to be 0.43, then what is P of A union B and what is P of A intersection B complement? Here they specify A and B as mutually exclusive events. So let's, if A and B are mutually exclusive, A and B are mutually exclusive, then what? Then probability of A union B will be probability of A plus probability of B. So it becomes 0.29. One more thing, this is also a PGCET question. I think this was 2013 question paper, plus 0.43. So that works out to 0.72. So that means definitely not the option D. It should be any of A, B, or C. That we will come to know only after evaluating the second probability. Now we have to evaluate what? Probability of A intersection B complement. Probability of A intersection B complement. Primarily, let us understand A intersection B complement. The question clearly say that both A and B are mutually exclusive. So as a Venn diagram, I can represent it as this one as A. I have to represent A and B as disjoint because they are mutually exclusive. So let me put this as B. The question talks about B complement. B complement means everything but not B. So the shading will be done like this. Okay. Now, this is what I shaded is only for B complement. Then I have to shade A, means intersection A means let me use vertical line only for A. Then what is the common region for A intersection B complement? It's nothing but A only because it is mutually exclusive, right? So I can simply say probability of A intersection B complement is nothing but probability of A. What is probability of A given? It is 0.29. Did I write it wrongly? Question. Just a minute. Let me check the question. Oh, I wrote this option wrongly. This option should be, the second option should be 0.29. Yeah, Sorry. So this is the option. Therefore, option B is the correct answer. Right. So this ends this particular session. In our next session, we'll see some more problems on probabilities. Right. So if you find the contents to be useful, I request you to like, share, and subscribe. Thank you.